Let us continue foundation chemistry. In that Iupac nomenclature we are seeing. In the Iupac nomenclature we have discussed already alkenes, alkynes we have discussed. Next we will go for some functional groups we will go. Now, what are the functional groups that we will see? Functional groups we will take. In the functional groups, one we can say that alcohol we can say. This alcohol formula is what in the sense? ROH we can say. This R in the sense, it is having some general formula. It can come under any category. Many examples we can say. One example, CH3, C2H5, that means methyl, ethyl, propyl, like this we can give. This OH is called alcohol. Alcohol means this OH group should be there. OH group is there means then we have to say alcoholic group we have to say. Okay. Sorry, alcoholic group alone we have to mention in the sense single bond O, single bond H. Like this you have to mention alcohol group alone in the sense. Next we will take a aldehyde we will take. Aldehyde we will take. For aldehyde how to mention in the sense RCHO, like this we have to mention. Aldehyde means this R in the sense we can substitute methyl we can substitute. Suppose N-butyl we can substitute. Anything we can substitute in the place of R. But aldehyde means what is the group? CHO. This we can write it as single bond C, double bond O, single bond H. Hydrogen will make always single bond. Oxygen will make two bonds generally. Two bonds in the sense that may be double bond. This is aldehyde we have to say. Next, carboxylic acid we can say. Carboxylic acid. This carboxylic acid in the sense general formula is RCOOH. This general formula. Carboxylic acid alone how to say means COOH. Here single bond is there. Single bond means this carbon is connected to something here. This carboxylic acid means COOH we can say. This COOH how to write in the sense single bond C, double bond O, single bond O, single bond H. It is carboxylic acid. Like this we can say ester we can say. Ester is the functional group. Ester how to write in the sense R, COO, R. Like this we can write. Now here ester means this COO, like this we can say. This we can write it as C double bond O, single bond O, single bond. Here single bond means this carbon is linked to some other group here. Here single bond means this oxygen is linked to some other group here. That is the meaning. So C double bond O, single bond O, like that should be there. This side what should be there means R group. This side what should be there means R group should be there. This is called ester we can say. Sorry. Next we can say that anhydride. Next functional group what in the sense anhydride. Anhydride in the sense C double bond O, single bond O, C double bond O, single bond. Here what we can say R group. Here what we can say R group. Like that we can say. This is anhydride we can say. Next we can say functional group what in the sense ketone. Ketone is the functional group. Ketone in the sense C double bond O, single bond this side, single bond this side. This side one R group, this side one R group. Like this we can say. Okay. Next we can say ether. Ether in the sense just single bond O, single bond. This side single bond one R group, this side single bond one R group. ROR, it is ether we can say. It is one functional group. Like this many functional groups we can say. Next cyanide. Cyanide we can say. Cyanide in the sense C triple bond N. Here one single bond should be there. That means here R group will be there. It is called cyanide. Next we can say isocyanide. Isocyanide in the sense NC we can say. NC. Here the bond we are giving here like this bond we are giving. Here one single bond will be there, R group will be there. It is called isocyanide. Isocyanide. Cyanide means CN we can say. Isocyanide means NC we can say. Like this many functional groups are there. Set. Now we will say how to say Iupac name for this. Iupac name in the sense prefix should be there. Then root word should be there. Root word in the sense from parent chain. Next primary suffix. primary suffix. Then secondary suffix should be there. Secondary suffix. Prefix in the sense, which will come as prefix in the sense branch, otherwise substituent. Substituent. Now, which is branch in the sense? Branch in the sense this carbon, the branch contains carbon. That carbon is linked to parent chain carbon. This carbon is not counted in the parent chain. So substituent. Branch also called substituent. Sometimes two functional groups will be there in the given compound. Out of two, one functional group will come as substituent. Okay, so this is about prefix. What about root word? Root word in the sense, you know that parent chain, we have to select in the parent chain how many carbons are there. As per that, we have to say root word. Then primary suffix. When primary suffix is what in the sense? Carbon-carbon single bond means we have to give N as primary suffix. If carbon-carbon double bond is there, then you give primary suffix as in. If carbon-carbon triple bond is there, you give primary suffix as ein. Okay, this is about primary suffix. Suppose in the given compound CC double bond alone is present, then you give primary suffix in. Suppose in the given compound CC single bond is present as well as CC double bond is present, then which primary suffix you have to give means as per CC double bond only you have to give. When there is no double bond or triple bond, when there is no CC double bond or CC triple bond, then you give primary suffix as N. If CC double bond is present, then you have to say primary suffix in. If CC triple bond is there, then you have to say primary suffix ein. Suppose CC double bond as well as CC triple bond is there, then what you have to do? Say in as well as ein. Okay. So we have to say in, we have to say as well as ein, we have to say. Therefore, if the given compound CC single bond is present, CC double bond also present, then primary suffix is as per CC double bond. In the given compound CC single bond is present as well as CC triple bond is present, then primary suffix is triple bond ein only we have to say. In the given compound CC single bond alone present, then you say en. In the given compound single bond is present, double bond is present, triple bond also present, then what you have to say? This en you need not say. You have to say in, you have to say ein. Both you have to say. So now we will take the compound in which CC double bond is present, CC triple bond is present, CC single bond is present. Like this we will take the compound. Okay. So now we will take the compound double bond, single bond, then triple bond. Like this we will take. Now what we have to do, how to say the name? First we have to select parent chain. So we will select the parent chain. It is a parent chain. In the parent chain, how many carbon atoms are there? 5 carbon atoms are there. Therefore, root word is pent. So then we have to say primary suffix. Primary suffix means what you have to do? See the bonds. CC single bond is there. CC double bond is there. CC triple bond is there. Then you say the name of double bond and triple bond. Don't say name of single bond. Okay. So double bond will say, triple bond will say. Then single bond name we need not say. Then we have to say the position, for which we have to give the numbering we have to give. Okay. So numbering will give. So here number 1, here number 2, here number 3, here number 4, here number 5. Okay. Double bond present between 1 and 2 carbons. Therefore, position of double bond is 1. Triple bond is present between 4 and 5 carbons. Therefore, position of triple bond is 4. Now, what we can cancel in the sense, this E we have to drop. When double bond and triple bond both are present, say the name of double bond in and say the name of triple bond ein later. Then first we have to say double bond position, double bond name in, Then we have to say triple bond name ein. In double bond name E we have to drop. In the double bond name last letter E we have to drop in order to make the word as one word. Therefore we can say pent one in four ein. One word it is. It is not two names. One name, one word. Iupac name should be in one word. Okay, so like this we said. So now we will go for functional groups. We will go now we will take the compound CH3OH. Here what functional group is there? You see OH group is there. That means alcohol group is there. Alcohol is the functional group. For this in this alcohol many general formulas are there. We will take one general formula CnH2n plus 1 OH. Like this general formula we will take. In alcohol, in the sense, not only this general formula, many categories are there. One category we have taken like this. Now n is equal to how much, in the sense n is equal to 1, 2, 3, etc. like this. Let us substitute n is equal to 1. If we substitute n is equal to 1, what we are getting, in the sense CH3OH. Okay, here let us select parent chain. Why to select parent chain? Only one carbon is there. Is there any necessity to say this is the parent chain? No. Okay, one carbon is there. One carbon is there means we have to say meth. Then primary suffix you have to say. Primary suffix means here only one carbon is there. When only one carbon is there, you say primary suffix as "-ane". When only one carbon is there, you say primary suffix just "-ane". Then we have to go for secondary suffix. Secondary suffix, here what secondary suffix we have to say means, secondary suffix for this alcohol we have to say. For alcohol, what is the secondary suffix? For alcohol, secondary suffix is the last two letters, that is OL is the secondary suffix. That OL I will write. Okay, secondary suffix is alcohol. For alcohol, what is the secondary suffix means OL. That OL I have written. Next, in the secondary suffix, first letter we have to take. If the first letter is coming under vowel sound, then drop the last letter E of primary suffix. If in the secondary suffix, first letter is vowel sound, in the sense, in the primary suffix, the last letter E we have to drop it. Then what is the name of this compound, in the sense we can say methanol. Methanol is the name of this compound. So CH3OH name is methanol as per Iupac. Okay. Next we will write n is equal to 2. We will write n is equal to 2. We will substitute in this formula. N is equal to 2 in the sense C2H5OH. C2H5OH. Here two carbon atoms are there. The two carbon atoms we will write like this. Then between carbon atoms, what bond we have to give? Between carbon atoms. Between carbon atoms, what bond we have to give, in the sense, if the formula, if you are writing the formula based on this general formula, if you write, then between carbon atoms we must give single bond. We are writing the alcohol in alcohol formula, we are getting from this general formula, in the sense, between carbon atoms single bond only possible. Okay, therefore in all the alcohols, between carbon atoms only single bond possibility is there or not, in the sense, if we take this general formula, only single bond. If we take some other general formula, CC double bond also possible, CC triple bond also possible. So that only I said for alcohol many general formulas are possible. We are taking one, and in the sense this we said. Okay, so as per this between carbon atoms you give single bond. Then you write this OH group, for one carbon you give this OH group. Give this OH group to one carbon. Okay, so for this carbon we have given OH group. Oxygen, for this oxygen we have given left side one bond, right side one bond. Why means oxygen will make generally two bonds. That two bonds will be like this, two single bonds, otherwise we can say double bond. Oxygen will make generally two bonds. The two bonds mean the sense two single bonds like this, otherwise a double bond. Okay, set here two single bonds we have given. Hydrogen means always one. Hydrogen will make always one bond only. Okay, sorry. Carbon in the sense it will make four bonds. Already two bonds are there. Remaining two bonds you give. For that hydrogens you give. Carbon in the sense here only one bond is there. Remaining three bonds you give it. For these three bonds you give hydrogens. Okay. Now we will write condensed formula. This carbon is having three hydrogens, therefore CH3. This carbon is having two hydrogens, therefore CH2. This OH will write. Okay. So CH3, CH2, OH we have written. Sir. Next, this we will make still more condensed in the sense that is C2H5OH. Like this we have given. Now, what is Iupac name? We will say here the parent chain contains two carbon atoms. Therefore, each we can say carbon-carbon single bond. Therefore, primary suffix is en, and OH is alcohol. OH alcohol is there. Therefore, secondary suffix we can say OL. Secondary suffix is OL we say. Now, in the secondary suffix, first letter is vowel sound. Therefore, in the primary suffix, the last letter E we have to drop. Therefore, the name of this compound is ethanol. Ethanol is a Iupac name. We are discussing Iupac name. For this ethanol, common name is there. Common name is in the sense generally called name. Generally called name is what in the sense? Ethyl alcohol. Ethyl alcohol. Like this, for this methanol, common name is what in the sense methyl alcohol. Methyl alcohol we can say. Methyl alcohol, why? Because CH3 name is methyl only, no? OH name is alcohol, no? Therefore methyl alcohol. It is common name. Like this, for this, this CH3 CH2, that means the C2H5 common name is commonly called ethyl. OH is alcohol, therefore ethyl alcohol we can say. Iupac name is ethanol, we have to say. Iupac name is ethanol. For this CH3OH, another name also there. What is that? Means wood spirit. Why? Because it is manufactured from wood. Therefore, it is called wood spirit. Like this, we will say. So, next, N is equal to 3, we will substitute. N is equal to 3 in the sense C3H7OH. This we will write. C3H7OH is there. This how to write in the sense here. 3 carbon atoms are there. Those 3 carbon atoms we will write like this. Okay. Then this OH group we will give to terminal carbon. Next, this OH group we will give to the center carbon. Like this I have given. Then carbon-carbon single bond you give it, because we are following particular general formula. Therefore, now for this carbon you give 3 hydrogens, because carbon will make totally 4 bonds. This carbon is having 2 bonds, therefore give 2 hydrogens. This carbon is having 2 bonds, therefore give 2 hydrogens. Okay. Now this carbon is having 3 hydrogens. This carbon is having 2 hydrogens. This carbon is having 2 hydrogens, and this carbon is having OH group. Now here this carbon is having one bond. So for this carbon give 3 hydrogens, you give it. This carbon is having 3 bonds, therefore give 1 hydrogen. This carbon is having one bond, therefore give 3 hydrogens to this carbon. Now we can write this as CH3, CHOH, CH3. Okay, like this we have written. Now let us select a parent chain to say the name. Here parent chain contains 3 carbon atoms. Therefore prop we can say carbon-carbon single bond. Therefore ane we can say. Then secondary suffix is alcohol, OL we can say. Then here we will see the parent chain. The parent chain contains 3 carbon atoms. Therefore root word is prop. Carbon-carbon single bond is there. Therefore primary suffix ane, and OH group alcohol is there. Therefore secondary suffix OL. Then this here we can drop this E, we can drop, we can say. Therefore here name is propane, we have written, and OL we have written. Here also propane we have written and OL we have written. Now in these two compounds, if you see, this alcohol is attached to terminal carbon, but in this compound this alcoholic group is attached to center carbon. Here alcoholic group is attached to center carbon. Here alcoholic group is attached to terminal carbon. So position of alcoholic group is different. Therefore, these two are which isomers? Position isomers. Why? Because position of functional group is different. Here alcohol group is terminal carbon. Here alcohol group attached at center carbon. So position of alcoholic group is different in these two compounds. Therefore, these two compounds are called what? Position isomers. Okay. Therefore, we have to mention the position of alcoholic group. We have to mention, for which we will give the numbering. We will give the numbering. We will give here number 1 carbon. Here alcohol is attached to first carbon. Therefore, we can say propane 1-ol. Here alcoholic group is attached to second carbon. Therefore, we can say propane 2-ol. Therefore, we can call this is as propane 2-ol. We can call this is as propane 1-ol. This propane 1-ol and propane 2-ol are what isomers in the sense position isomers we can say. So for C3H7OH position isomers possible. Sir. Next, N is equal to 4 we will take. N is equal to 4 in the sense C4H9OH. Now, here 4 carbon atoms are there. 4 carbon atoms we will write like this. And OH group we will give a terminal position. Sir. And another possibility is OH group we can give at second carbon, like this, 2 possibilities. Then let us write this last carbon to this center we will bring. So 3 carbon straight we will write, 1 carbon down we will write. This OH we will write it at first carbon itself. Next we will write this OH group we will write at this carbon, center carbon. Then we will get like this. Okay. Then let us give hydrogens now. Now we can say this carbon is having single bond, so let us give 3 hydrogens. This carbon is having 2 bonds on either side, therefore we will give 2 hydrogens. For this carbon 2 hydrogens, for this carbon 2 hydrogens. This carbon is having single bond, therefore give 3 hydrogens. For this carbon 2 hydrogens. This carbon is having 3 bonds, so give only 1 hydrogen. For this carbon 3 hydrogens. So now we are giving hydrogens to the carbons depending on the requirement. Okay, for this carbon 3, for this carbon 3 hydrogens, for this carbon 3 hydrogens. This carbon is having 4 bonds, therefore don't give any hydrogen to this carbon. Okay, so now we have written the possible isomers for this C4H9OH we have written. Now let us say Iupac name for these compounds. We will say first we will select parent chain in each case. Here parent chain is this. This parent chain contains 4 carbon atoms. Therefore, we can say but is the root word, and the primary suffix we can say en. Secondary suffix we will say ol. Okay. Then let us give numbering. Here number 1 we will give. Therefore, alcohol position is first position we can say. Let us select here parent chain. Let us select here what is the parent chain in the sense this is the parent chain we can say. Now this parent chain contains 4 carbon atoms. Therefore, but is the root word. Primary suffix is en. Secondary suffix is ol. Then here let us select a parent chain. The parent chain contains 3 carbon atoms. Therefore, root word is prop. Root word is prop we can say. Primary suffix we can say en. Then secondary suffix we will say ol. Now this CH3 is not in parent chain. Therefore, it is branch. This branch name is what in the sense methyl we are saying. Methyl is the branch name. Then here we will take here parent chain we are selecting like this. The parent chain contains 3 carbon atoms. Therefore, primary suffix is en. Secondary suffix is ol. This CH3 is not in parent chain. Therefore, we have to say this CH3 as a branch. The branch name is what in the sense methyl. Okay, we said names for this. Let us give position now. Position will say here position is 1. Here if you see the if you give the position what we have to give means here number 1, here number 2, here number 3, here number 4. Now this OH group is attached to second carbon. Therefore we are saying butane 2-ol. Okay, here let us give numbering. How to give numbering here? Shall we start from left or right in the sense start from right? Why? Because this OH group should get least position because it is functional group. The functional group should get least position. Therefore, start numbering at this right terminal. Okay, here number 1, here number 2, here number 3. Now this methyl group is attached to second carbon of parent chain. Therefore, position of this branch is 2 we can say. This functional group OH is attached to first carbon of parent chain. Therefore, position of this OL is 1 we can say. In the same manner, let us give numbering here. Numbering in the sense you start at left extreme of parent chain, otherwise start at right extreme of parent chain numbering. Don't start at center. Okay, therefore here number 1, here number 2, here number 3 we have given. Now alcoholic group is attached to second carbon of parent chain, therefore position of alcohol is 2. This methyl group is the branch here. This branch is attached to second carbon of parent chain, therefore we will say 2-methyl we can say. So Iupac names of these compounds we said. Now for this C4H9OH, these many isomers possible we said. Now we will say these are coming under which isomers, either chain isomers or position isomers. In which isomers they will come, that we will see. Now we will take this is compound A, this is compound B, this is compound C, compound D. Now let us take A and B we will take. This A and B comes under which isomers you see. In A, alcohol position is 1. In B, alcohol position is 2. Therefore, position of alcohol is different. Therefore, this A and B are called position isomers we can say. Then we will take B and C we will take. In B, parent chain contains 4 carbon atoms. In C, parent chain contains 3 carbon atoms. Therefore, parent chain length is different. Therefore, B and C are called chain isomers we can say. Then in B, position of alcohol is 2. In C, position of alcohol is 1. Therefore, position of alcoholic group is different. Therefore, this B and C is also called position isomers we can say. Next, we will take C and D we will take. In C and D, if we see, position of alcoholic group is different. Therefore, C and D is called position isomers we can say. Like this, you can make the sets. Which isomers we can make the sets? Suppose you are taking AD. AD in the sense, shall we say, position isomer as well as chain isomers? Yes. BD you take. BD if you take chain isomers you can say. BD in the sense chain isomers you can say. So like this, we can say isomers. Okay. So in this way, you can try for n is equal to 5, n is equal to 6. Like this, you can try. Okay. So we said about here alcohol functional group we have seen. Now we will go for a next functional group called aldehyde. We will take. For aldehyde, how to say the name that we will see. Aldehyde in the sense RCHO we can say. Aldehyde general the aldehyde formula in the sense RCHO we can say. In the place of R we can take suppose CnH2n plus 1 we are taking. Okay. In the place of R we have taken example CnH2n plus 1. Not only CnH2n plus 1, many are possible. Okay. So now here n is equal to 0 possible, n is equal to 0 possible, n is equal to 1 possible. Like this it will continue. Now let us write n is equal to 0. If we write n is equal to 0, then we can say formula HCHO. HCHO we can say. Okay. This HCHO we can write in what manner? Means H single bond C double bond O single bond H. HCHO like this we can say. Now what is the Iupac name of this one? That we'll see. This compound contains 1 carbon, therefore root word is meth. See that if the compound contains only 1 carbon, then say root word is meth. Okay. This carbon of course present in the functional group. Even then this functional group carbon certainly comes under parent chain. Okay. So this functional group carbon should be going towards root word. This functional group carbon contains 1 carbon. This compound contains only 1 carbon. Therefore, root word is meth. If the compound contains only 1 carbon, then say primary suffix "-ane". Then here, what is the secondary suffix means? Here, this functional group is aldehyde. In the aldehyde, first 2 letters you take, that is the secondary suffix for this functional group. So secondary suffix is what in the sense Al. This secondary suffix, first letter you see, it is vowel sound. Secondary suffix, first letter is vowel sound means primary suffix last letter E, you have to drop it. Then the name of this compound is what in the sense methanol we can say. Next, n is equal to 1 you substitute. N is equal to 1 if you substitute, you will get CH3 CHO, you will get it. Okay. CH3 CHO. For CH3 CHO contains 2 carbons, therefore root word is what in the sense eth. Primary suffix is en, secondary suffix is al. Therefore CH3 CHO name is what means ethanol we can say. Then n is equal to 2 you take, n is equal to 2 means C2H5CHO. This C2H5 you already know that we can write this as CH3CH2. The CHO we will write it like this. Here parent chain contains 3 carbon atoms, therefore prop is the root word. Primary suffix an you write, secondary suffix al you write, therefore we can say the name propanol is the name of this compound we can say. Next we will substitute n is equal to 3, we will substitute n is equal to 3 in the sense we can say C3H7 then CHO. The C3 how to write in the sense 3 carbon atoms we can write like this, CHO we can write like this. Okay, next possibility, in these 3 carbons this last carbon will write branch of this we will write, so we will get like this we can write. Okay, now we will give hydrogens, we will give for this carbon let us give 3 hydrogens, for this carbon 2 hydrogens, for this carbon 2 hydrogens, for this carbon 3, for this carbon 3, for this carbon 1, like this we have written. Okay, now let us say the name of this compound. Now here parent chain contains 4 carbon atoms here. This parent chain contains 4 carbon atoms. 4 carbon atoms in the sense but we have to say primary suffix en, secondary suffix al. Okay, now in this case, what is a parent chain means the parent chain should be longest continuous carbon chain. In that functional group carbon must be present. Okay, so here parent chain means what? Longest continuous carbon chain. In that functional group carbon must be present. Therefore, parent chain you have to select like this only. Don't select like this. Okay, so of course number of carbons coming same, but even then the functional group carbon should be present in the parent chain. So the parent chain contains 3 carbon atoms, therefore we can say prop. Primary suffix we can say en, secondary suffix is aldehyde functional group, that we have to say al. Then now we have to say branch name. This branch is what in the sense CH3 here, that name we have to say as a prefix what in the sense methyl. Then we have to say the branch position, we have to say the branch position we have to give numbering. How to give numbering in the sense functional group carbon should get least position. Functional group carbon should get what? Least position. So how to give numbering? Start from functional group carbon you start. Okay, so functional group carbon should get least position. Therefore start giving numbering at functional group carbon you start it, because it is at extreme only, it is also right extreme. Therefore you start numbering from right extreme. So numbering we are giving like this, methyl group present at second position, so we can say 2 methyl propanol we can say. Now we will see these two, it is butanol, it is 2 methyl propanol. Are they isomers? Of course they are chain isomers. Why chain isomers? In the sense here parent chain contains 4 carbons, here parent chain contains 3 carbons, so parent chain length is different, therefore these two are called chain isomers we can say. Next n is equal to 4 we will take, n is equal to 4 means C4H9CHO. Now for this what are the isomers possible we will see. Here 4 carbon atoms are there, 4 carbon atoms we will write like this, and CHO will write like this. Next this last carbon let us bring below this. So last carbon we will bring below this. Okay, so we have written like this. Next this branch carbon you write under this you write, therefore you will get like this you will get. Okay, so these are the possible isomers for this compound. Let us give hydrogens, then we will give the name of these compounds. We will give for this carbon let us give 3 hydrogens, here 2, here 2, here 2 we will give. Now we have given the hydrogens we have given. Now we will give here 3, here 2, here 1, here 3 we will give. Here 3 hydrogens, here 1 hydrogen, here 3 hydrogens, here 2 hydrogens, like this we have given. Now then we will say the name of this compound. This compound contains 5 carbon atoms, therefore pent, primary suffix is en, secondary suffix is al. Okay, now here so let us select the parent chain. Parent chain is this one. Parent chain contains 4 carbon atoms, therefore but, primary suffix is an, secondary suffix is al. Then this CH3 coming under branch, this branch name is what in the sense methyl. This branch position we have to say. Now we have to give numbering. Numbering how to start in the sense if aldehyde is a functional group, then start numbering at aldehyde carbon only you have to start numbering. If aldehyde acting as a functional group means you start giving numbering at aldehydic carbon only. Don't consider branch position. Okay, aldehydic carbon should get first position if aldehyde is the functional group. Okay, then numbering we have given. Now the branch position is 2, therefore 2 methyl. Okay, now can you say the name of this one? Shall we start numbering from left here? No, we have to start numbering at which carbon? Aldehydic carbon only we have to start. Therefore, we have given numbering like this. Here parent chain contains 4 carbon atoms. Therefore, branch name is methyl. Methyl is present at third position. Therefore, we can say 3-methyl butanol. 3-methyl butanol. Aldehyde is a functional group means aldehydic carbon should be given number 1 position. Therefore, we need not say position of this Al. Position of this Al we need not say. Okay, sir, we have written the isomers now. Shall we say these two are called chain isomers? Yes. These first and last are called chain isomers. Second and third, the second compound and third compound are called position isomers because position of branch is different. Therefore, position isomers like this we can say. Now, in this way, you can try for n is equal to 5, you can try n is equal to 6 also, you can try. Okay, then we will take next isomer, we will take next functional group, we will take that is ketone. Ketone is the functional group. For ketone, we can write RCO, or we can write for this, or let us take one example CnH2n plus 1. For this also let us take CnH2n plus 1 like this we will take. Okay, here in the place of our the formula, general formula need not be CnH2n plus 1 always. We have taken one example, that's all. Okay, this n is equal to what in the sense n is equal to 1, 2, 3 like this. Okay, here n is not at all 0. N is not at all 0. Okay, here also n is equal to 1, 2, 3 like this. Here n is not at all 0. Okay, so let us substitute n is equal to 1 in both cases. Therefore, we will get CH3, CO, CH3. Okay, what is the Iupac name? We will say here root word is prop because 3 carbon atoms present. Primary suffix is en. Secondary suffix is what? Here secondary suffix is what in the sense this last 3 letters of ketone, last 3 letters what in the sense on. Now in the secondary suffix first letter is vowel sound. Therefore, let us drop e from the last letter from the primary suffix. Therefore, what is the name of this compound in the sense propanone? Propanone is the name of this compound. Okay, next I will take this side C2H5, this side CH3 I will take. Right side CH3, left side C2H5 I will take. This C2H5 I can write it as CH3, CH2, then remaining part we will write like this. Here 4 carbon atoms are there, therefore root word we can say but, we can say primary suffix we can say en, secondary suffix we can say on. Butanone like this we can say. Okay, so like this is about ketone we can say. Next I will take one compound CH3, CH2, CH2, CO, CH3 like this I have written. For this I can write isomer. How in the sense CO right in between these two carbons, then we will get CH3, CH2, CO, CH2, CH3 like this you can write, isn't it? So that here 2 isomers possible. Here parent chain contains how many carbons in the sense 5 carbon atoms are there, therefore pent, primary suffix is en, secondary suffix is 1. Here parent chain contains 5 carbon atoms, therefore pent, primary suffix en, secondary suffix is 1. Okay, now in these two, what is the difference in the sense position of ketone is different. Therefore we have to say the numbering. How to give numbering in the sense first you select the parent chain. In the parent chain you start to give numbering either from left extreme or from right extreme. Okay, start giving numbering from right extreme, otherwise left extreme, such that ketone position should be least. So you follow it from left or right. Ketonic carbon position should be least. For that, in what way we have to give numbering, as per that you give it. Okay, so we can give numbering in what way, in the sense right extreme we will start, then only ketonic carbon will get least position. Therefore, here ketone carbon is getting what position in the sense second position.